And we are live. Good morning, everyone. Hopefully, everybody's having a wonderful Friday. My name is Bryan Armentrout with the Food Safety Foundation, and as always, on Fridays at 10 a.m. Eastern, here with my good friend Jose Sabal of Jose Sabal Food Safety Consulting. How are you today, my friend?
I'm very well. Very tired. This has been oh my goodness, a very busy, a week. I'm going to say, but yes, fine. Brian, everything is fine.
Yes, I think things out there are starting to get back to normal, right? And things are picking up, and so I'm seeing that too, right? Lots of activity out there, which is good. That's a good thing. We like that. We want safe food, and we can help with that. So every Friday on LinkedIn, Facebook, YouTube, Twitter, we do a live stream and we talk food safety, which is something unique, right? This is not a presentation. This is not a bunch of slides that we go through. This is a discussion. It's an interactive discussion around a topic. And what's cool about this too, Jose, is that we take feedback, right? We want topics from people on different things from food safety, manufacturing, and different processes that you want to know more about or you have questions on. That's the fun thing about this. And so one of the things that we always do is we start off and say good morning to everyone and check in from where you're at. I am in Loveland, Colorado, where today, Jose, it's going to be in the low 90s here.
Today, low
Yes.
90s?
Mm-hmm.
Oh my goodness. We're not we're not there even yet. Wow. What a swing, Brian.
That's Colorado. But what's nice about it is there's no humidity here. So at night it cools down and you can open your windows and all those type of things. But during the day, you don't want to do that. Good morning, Luis. Good morning to our friend Brian, getting up early out in San Diego. Welcome, my friend. Always good to see you on here. You can kind of see, I can't wait anymore on this. I got to kind of bring this up. So you can kind of see him here. So this is a website called giantmicrobes.com. No affiliation. It's just, I think these are freaking cool as hell. So this is a T4 phage, right? So you got the little feet there, right? Sucking on the bacteria. So a bacteriophage, right? So this attacks attacks bacteria, not people, right? So it's not like another type of virus, but they've got salmonella and listeria and all kinds of nerdy cool stuff like that. So I just think it's really awesome.
We have someone from India.
Oh, wow. Good.
Yeah, should be late for them. Actually, for Nilesh, should be late for you.
Current time in India. Let's see. I'm curious. Let's see here.
I believe it's 14 or 15 hours different.
Pretty much the opposite side of the world. Yeah, so it's 7:30 p.m., which is very interesting because when you look at the time maps, the entire country of India is off from everybody else. They're at a half hour, and the entire country is the same, which is kind of cool.
Really?
Yeah. Look at one of those time zone maps sometime. So
okay.
Better than having the country split in half, right? So that's good for them. So good morning and good evening from India, which is why, you would think that the time there would be 8 p.m., right? But it's 7:34, which is kind of different. My friend Roque, hello from Philly. Good to see you, my friend. Today is an interesting topic. It's kind of a far-ranging topic, right? And if you're working in food safety and food quality, Jose, it's a hard one, right? It's sampling and how you manage those programs, right? Really, really difficult. And so we're gonna be going. I expect for our conversation here today, Jose, we're gonna be going all over the place on how these different type of things for sampling can work. So we have, we have a very international group here. We got Mitzi. Nice to see you. In Tunisia, so we have Mohammed in Singapore. We have a person in Canada. Wow, this is amazing. Awesome. We're really happy that everybody is here. And as we're talking about our sampling conversation here today, as we said, please, as we're going along, type in your questions for us. Or if you have suggestions on things or resources or things like this, Brian's really good at this, is put those in the comments too, right? This is about interaction and sharing because food safety and food quality and all these type of things, right? Especially food safety, right? It's something we all need to collaborate on. And here at the Food Safety Foundation, that's what we work on. So let's all work together to make things better. But before, Jose, we get started, everybody join us.
Oh, yeah.
For
I need this today.
Our drink together, right? So I have coffee, and of course, Jose has tea in his beautiful flowered cup. So join us for a sip.
Oh, yeah.
I, of course, have my coffee. Tasting extra good here this morning on this beautiful Friday day here in Colorado. So, guys, sampling, Jose. Where do you even? What's the best place to start with sampling, right? So
Oh my goodness.
You're a quality manager, right? And you have all of these different ways that you need to look at sampling. And part of it then, and one of the things that we always start off with these conversations is the regs, right? What are the regs saying, right? This is always what you should go to first, Jose.
Yeah, that is right, Bryan. And you know what? The only thing that we have as kind of a guidance for sampling, it's in the preventive control for human food, because over there, if you guys are working with ready-to-eat products exposed to the environment, before packaging, the FDA says that you must address in your hazard analysis environmental hazards. So in 117, 165B3, it says that you must have written procedures for environmental monitor as required in this section, which is 117, 165, and it says that the environmental monitoring must be scientifically valid, must identify the test organisms. But then in Roman number 3, it says, identify the locations from which samples will be collected and the number of sites to be tested during routine environmental monitoring. Mm-hmm. The number and location of sampling sites must be adequate. And watch out, because there is a definition for adequate in the regulation to determine whether the preventive controls are effective. And the next section says, identify timing and frequency for collecting, testing samples. The timing and frequency for collecting and testing samples must be adequate, again, in order to determine whether the preventive controls are effective or not. Now, what I would like to do, Bryan, now is go through the definition of adequate in the regulation, which is adequate means that which is needed to accomplish the intended purpose in keeping good public health practice.
It's pretty vague.
It's very wide, I will say. But yes, if you ask me, what is the definition of adequate? Is anything that is going to be effective, anything that is going to work in order to prevent any kind of a public health issue.
Right. Interesting. And so on a previous chat, we talked about, we did a deep dive into environmental monitoring. And in the FDA inspection manual, right, the guidance, the Bible FDA uses when they're going into facilities, chapter 4, very specific, right, around how they are doing that. And FDA internally, right, so they take this definition of adequate and then they say, okay, here's how we view adequate, right, for zone 1, 2, 3, 4. And here's how we're going to sample. And here's what we're going to do for facilities under 20,000 square feet. And anything bigger than that, here's what we're going to do, right? So FDA has taken that very broad definition then, and on their side, narrowed it down, right? So we need to be doing the same thing on our side.
Yep. And actually, one thing that, I mean, look at you and me, Bryan, and I believe that this happened to many other people. All of these standards that says you need to have a program for sampling and testing. What normally we see there? Oh, we're going to be sampling and testing with swabbing or ATP, or we're going to take some samples and send it to a lab. That is testing, what you're actually talking about, and the methodologies that you're going to be using for that specific organism that you select or whatever it is. But that is testing. Sampling is about finding out what is the best methodology that we can use in order to determine which is the right amount of samples that we're going to take from a lot in order to determine if statistically the outcome of the entire production is going to be okay or no based on the test results.
Yeah. No, that's a good point. Good point. And that's the hard thing in the food industry, right? At a previous company in the past, I went through and they spent a lot of money putting a bunch of us through Six Sigma black belt training. And so I'm a registered, black belt and that type of stuff. But here's what's interesting in the food industry. Unlike automotive or aerospace or things like this, there's a flaw in the food industry when it comes to Six Sigma analysis and things like this. And I think this is why these type of programs haven't been very well instituted. Now, this may be controversial. I may get jumped on the comments for this, but this has been my observation, is that the food industry is too variable to really execute Six Sigma principles, right? Where you're looking at your bell curve, right? And you got your Six Sigma tolerances, 3 Sigma on each side, and you're looking at keeping those things under control. But if you're making cheese and that milk, every single day, that milk that is coming in is different, right? Your standard deviation on those type of processes is huge, right? So you're constantly reacting and changing. And it's very hard to then apply those methodologies to the process. So you're kind of back where you started from that side. So then how do you do those type of things? So really, I think it's important to look at this, Jose. First, when you're thinking about these type of things, you need to say, all right, what's my purpose? Why am I doing these things? And you need to kind of first look at this and bucket your programs and say, okay, well, what type of sampling do I have to verify that these things are working, right? You have chemical analysis, right? So you're doing pH or salt or temperature or things like this, right? Those things are pretty tight, right? And if you're looking at, to your point, a lot, if you take a pH out of a 50,000 gallon silo, pretty much every sample you get is going to be very close, right? If you've got good agitation in the tank and everything is the way it should be, your pH is going to be pretty ubiquitous throughout that entire tank.
Yep.
Now, micro is different, right? Micro clumps, right? You have biofilm on the side, or you've got a colony of cells growing over here. These type of things, right? So people often think that micro testing is the same as chemical testing, and it's not, because bacteria may or may not cooperate, right? You pull a sample and you happen to pull it in an area where you have bacteria, and you plate it up, and they're like, nah, I don't want to grow, right? And you think that you don't have anything, when in reality you do. So from a statistical standpoint, now you're in a non-homogeneous situation, which means then, right, sample size goes up, and that can really, really cause some problems. There's a third group too, Jose, that people forget about too, is all the organoleptic criteria that you're looking at in your plant.
Yes.
Flavor, color, texture, all of these type of things. How are you going to manage those? Because in the quality function, right? So we're talking food safety, food quality, operations, all these things that we're managing in a plant, is really what we're doing from a quality side is we're taking what the company wants to be made, right? So the R&D guys and the marketing guys, right? They do all this work and they do trials and all these things, and they come up with something they like. And the consumers say, I love this, right? They then hand it to us on the quality side. And they say, here, take care of this. We want this just like this. So then your job, right, is to figure out, back to our topic for today, what is the right sampling methodologies and processes to make sure that we get what we think we're going to be getting.
100% with you. And actually, Bryan, yesterday I was reading a little bit, refreshing my mind about sources. And one very typical source that is used basically universally is the Codex Alimentario Sampling Plan. 233 is the number. And you know what is very amazing, that when you read that section, and that section is Appendix 1 of the manual, they are giving you for acceptable quality limit of 6.5%. They're giving you different tables according to the weight or eventually content of the product. So you're not going to be sampling exactly the same way, like you mentioned, liquids from solids, from, I mean, powders eventually when you don't have that perfectly mixture of things. And depending on the quantity of the unit that you select for sampling, whatever is that unit, if and I'm reading right now here, if you have something that is less than 1 kilo, 2.2 pounds, this is your sampling site. But if you have more than the 1 kilo, 2.5, this is your other sampling plan. And if you are above 10 pounds, this is your different sampling plan. And the quantities could be the same, but the sample size and the acceptance number is going to be different just because of that.
Interesting. Yeah, I think that kind of really. We have a question here from India, from Nilesh, right? So he's asking a very specific question around here of products coming into the U.S. from India. What's the SOP for taking control samples? How to match analysis with USA, because analysis in India, right, you have made different methodologies. Please suggest right way to sampling of food, especially frozen food. Ooh, very specific, and off the top of my head, I don't know that.
Yeah, and again, I'm not sure, Brian, if in this chat we can say, oh, this is the methodology that you need, because again, it's going to vary so much according to the different products that are being made and the different units and production. Actually, one of the things that I did yesterday is this exercise. If you go to the definition of acceptable quality limit, AQL, okay?
Mhm.
It is very common that you are going to see, oh, well, most people are going to use 6.5%. Okay. So what is the definition of AQL? And actually, let me see if I can pull that. There you go. I have my definitions here. So acceptable quality level is the maximum percent of defective units permitted in a lot, which will be accepted about approximately 95% of the time. So you look at that, Brian, and again, going back to a statistics, and you're going to say, hold on, 95% of the time, what that means. So I said, okay, let's say that I'm going to produce for 100 days, one after the other, okay? And I'm going to produce, to say something, 1,000 pounds each and every single day of whatever is the product, okay? The total production is 100,000 pounds, okay? Now, if the acceptable limit, the AQL, is going to be within the 95% of the time, that means that we accept a lot that is going to be that is going to have a 6.5% deviation from 95,000, because that is your 5% difference of the 95% acceptable. So that means that you already have 5,000 pounds that are not, statistically, are not going to fit into the okay. Plus the 6.5% that you are using as your reference for calculation. So I made the math, and the outcome was 11,000 and something pounds.
Wow.
Now, the example that I'm always using when I'm teaching something related with sampling is this. So, as a general approach, when you do something once, whatever is the outcome, okay, the outcome could be exactly what you're expecting, or could be totally the opposite of what you're expecting, okay? So, whatever is the outcome, when you're doing something once, you have basically 50% chances of getting that right and getting that wrong, statistically. Okay.
Yeah.
So how do you improve whatever is that outcome? And again, I just don't care if it's okay or not, or yes or no, or black and white, whatever is the outcome that you are expecting. So now let's say that we want to say something. We want white. We want yes. Okay, so if I do something one time, I'm going to get a yes, but that yes is only 50% of the chances because we have another 50% that could be no. We're just doing
Right.
that thing one time. Now, if you do that again, what you're actually doing is cutting the no in half, adding 25% to the first 50, and leaving the 25% in the no. So now, once you do something twice, 75% of the time, you are going to have the same answer because now you have the evidence statistically, but you still have 25% chances. So if you keep on doing that same thing over and over, when you reach a, if I'm not wrong, 7 test, you are 99.2. And when you reach 14 tests, you are going to reach 99.9. Now, what I'm always telling people is this. You're going to say, okay, so you want to be, 0.8% is fine with you? Yeah, now, 7 tests, 99.2, that's fine with me. Say, okay, now look at this. Let's say that there is a company, and I'm going to use this real example. So when I was working in South America, there is this crab meat company, and we were producing 2,500 cans per day of pasteurized blue crab meat. Okay. Let's say that in order to round the thing, let's say that we were producing 1,000. Okay. And let's say that it's 99%. So I'm looking at 1%. 1% of 1,000 is going to be 10 cans. Isn't that right?
Yep, 10.
I believe I have the right math. Okay, so 10. So that means that from my daily 1,000 cans, I'm sure that 990 are going to be fine. But I have no clue what's going on with those 10. Okay? And maybe you're going to say, you know what? The risk of the company for 10 cans, it's fine. I'm okay with this. I can live with this. Because, for example, let's say that from 1 pound can, maybe 1 or 2 people will eat from that. So you multiply that with the number of people that will get sick if there is something wrong, blah, blah, blah. And you get with an acceptable thing, in quotes, acceptable, because a disease is just not acceptable, not even one. Now, let me give you the other scenario. So now, instead of having a production of 1,000 cans, you have a production of 1 million gallons of milk. And your unit now is the gallon. How many people drink from a gallon of milk? And how many times? How many people may get sick? And now, what is 1% of 1 million? And you're going to have what, 10,000?
Right, now you're up 2.
Okay, so is it acceptable to have 10,000 gallons of milk that will be drunk by, 4 or 5 people, whatever? Is that acceptable? No, but the AQL was exactly the same.
Yeah.
So again, these are the things that people need to consider whenever people is deciding to use whatever is the sampling plan that everybody's going to put in place.
Right. I mean, part of this too, right, is a lot of when you pull up online and you say, okay, I want a sampling plan for this, and these type of sizes and things like this. This is also tied to a static lot, right? Which is not the case either. So you don't wait for a finished lot of material and then say, okay, now I'm going to test and decide whether to accept or reject it. That's crazy. So what we do is we have for our process, sampling in process, where we're looking for mistakes as they happen too, right? Because we don't want to produce a lot of 1 million gallons of milk and then have 10,000 of that and it fails and we have to reject the whole thing. You can't, you'll be out of business really quick, right?
Yeah.
So then part of this then is setting up for receiving, processing, warehousing, all these different processes within there. How do you then sample within that, right? Because the rule in quality is that for every step you go down the process, you're adding 10x to the cost of finding that defect, right? So you want to find it as quickly as you can.
Yes.
And do it with the most efficient sampling plan that you can, because a lot of times the young quality people will go online and they'll do a Google search and they'll say, okay, statistical sampling plan. And to your point, Jose, right? They'll go, okay, I want 95% confidence. I want this CPK and blah, blah, blah. And they pull it up, right? And they end up with, oh, okay, I need to pull 350 samples. Right?
Yeah.
No, not going to happen.
Yeah. You're right.
Not going to happen. So this is why we have in-process sampling, right? Because you can't wait for the end. And if you confuse those things, right, you're going to make your plant manager really, really unhappy when you start sampling hundreds and hundreds of samples for that incoming shipment.
And you know what is the other thing, Bryan? The fact that we are going to be taking samples from a lot. Okay, so define a lot. If I go here, there is a very, clear definition of our lot. Let me, food, hold on, let me find that. Lot size is the number of primary containers or sample units in the lot. So hold on, sample unit, sample. Okay, I don't have the definition exactly for the lot. But look at my point. So what is a lot for some people? Well, for some people is the manufacturing of the product on this day, between this time and this time. For other people, it's going to be, well, we're going to have a lot every 2 hours, every 5 hours. For some people, it's going to be a 24-hour run. Mm-hmm. And different companies and different products are going to have different sizes of the lot. Okay? And then I'm going to start mixing the lot size with the actual cut that you put in production to fully separate one lot from the other.
Yes.
Because that is going to be key in this definition. And something that people do not realize many of the times, Bryan, is that all of the elements of the system, which are the different programs that we have in place for food safety, calling them, making sure that the water is safe, that we have pest control, that we have clean and sanitation, that we have calibration and whatever, they must have cuts that match the size of the lot. You know what? Because if you say that, and I'm going to the extreme, let's say that I'm producing oils, when this is an industrial site and my lot is 1 day of production, so it's a huge lot. But now, for that process, you're using water, and you say, I'm going to rely on an annual water quality test from the city. My goodness, if you have a deviation in that problem, your lot is 1 year, not 1 day.
Right. So, going back to your earlier statistical example, Jose, is that big lots equal big problems, right? You're increasing your potential risk associated with that. So this is another balancing act. You have to figure out what's the right size of lot. And so I always refer to this as bookending. So we'll use cheese manufacturing again as my example. So let's say that you're a cheese manufacturer and you're producing mozzarella cheese, and your production day is a lot, right? You clean at night. So you clean during third shift, you run through first and then second, and then you repeat that cycle, right? That's your lot. Right. And so when FDA comes in and says, what's your lot size? That's what you would talk about. But what a lot of people forget about is rework and things like this, right? That jump.
Oh, yes.
Wall. So, for example, in mozzarella cooking, you have the cooker stretcher, right? So after you make the curd, it goes into the cooker stretcher and it pulls and kneads the cheese, right? And that's what makes it like string cheese, right? It makes it nice and stringy. Lots of hundreds and hundreds of pounds are left in that machine at the end of the production day. And the plant manager goes, well, I can't throw all that cheese away. So they pull all that out and they use it for the next day. Guess what? You now have a continuous lot because you're always jumping that wall. And so when you see a recall, when FDA goes in, this is one of the first things that they establish, right? Is what is your lot?
Yep.
And then they'll start looking for that rework. And a lot of times when you see a recall, and then all of a sudden a notice comes out a week later and the recall is bigger. That's why, because FDA went in and found out that what you thought was a lot size is not the lot size because it's continuous. It's continuous. So you have to break. So in that cheese example, what I put in place in my plants is on a periodic schedule, depending upon the risk we were comfortable with. right? The riskier the product, the
Yeah.
smaller the lot. We would
Yeah.
then throw away that cheese in that cooker stretcher because we wanted to break that. So mozzarella is not as risky as ricotta, which is not as risky as brie, right? So the riskier the product, the smaller you need to make your lot so that you can isolate that risk with your sampling plan.
Yeah, and even though Brian, that you're talking about cheese,
Mhm.
if I recall properly, you remind me if I'm wrong, but it's one of those products in the traceability list now because of the amount of recalls and the amount of product adulterated.
Right.
So it doesn't matter what kind of cheese it is. You are working with a high risk product. And at that point, something I'm always saying during consulting or training is the higher the risk in your hazard analysis. You don't need to go anywhere. You have that risk in your hazard analysis. The higher the risk, the more frequent you are going to be performing those control procedures. And
Right.
the more frequent you should be cutting the lots in a way that is effective between one lot and the other. There is no connection between those two.
Right. Yep, absolutely. And as our friends at Peanut Corporation of America know, if you're looking for micro, you can't go back and resample, right? Oh, we got a positive. Okay, well, let's do
Yeah.
another sample. No. Absolutely not, right? A negative does not negate a positive, right?
Yeah,
You have
of
a positive
course.
result, that's what you got, right? Now, what you can do is begin investigating, to your point, Jose, to see if you can find out the source, right? Where did it occur? Do you have a spike during your production run and then it trails off? Was there a point event or was it through the entire run? You need to find those things out. But the judge has ruled, right? There's no going back, right? You can't negate that.
Brian, look at this. Oh, you have a lot. Whatever is that lot size? Okay, well, we're going to say I'm going to use the Peanut Corporation. Let's say that thing was, I don't know, 1,000 pounds to say something.
Huh?
If you take one sample of those 1,000 pounds, yes, I know that the analytical method is going to tell you, well, this method is accurate up to whatever. I'm going to say a number, 80%. So 80% chances is that you are going to get the right result. That A is not present, but you still have 20% chances of getting, a negative when actually it was positive. So again, it will play the same rule. So in this case, you test once. That means that you are going to have 80% chances to get it the right answer and 20% chances to get, oh, you know what? This is a positive, and it is not. So what you do, again, based on the sampling plan, you take as many samples as necessary according to the accuracy of the methodology in order to reduce the likelihood of having something wrong.
Right. So you need to look at these things in terms of, yes, what is the associated risk and how often do I need to sample these particular things, right? So you need to look at this in terms of your different steps in that process again, right? So this is where you then are going to put together your sampling plan for suppliers, right? Okay, here's the different things I bring in.
Yes.
Here is the risk with these different materials. And here is the risk associated with the supplier itself. Do I know the supplier? Do I have a track record? What data do I have to paint a picture, right? Because over time, this becomes clearer and clearer, right? Of what is my deviation associated with this, right? So it's not only the material, it's also the supplier, right? So you should have a sampling plan in place for new suppliers versus established suppliers, where you're pulling more samples when you're looking at new suppliers. Because if you're just taking the COA and taking their word for it, really?
There is bias.
Right. Or if you're saying, send me a pre-shipment sample. Okay, how did they sample? Where did they pull from? Is that sample really representative of what they sent you? Or was it just something they pulled out of a bag at the end of the production run? I don't know. Right? Who knows?
Good point.
You could be fooling yourself into thinking you're in compliance when you're not.
Yep, 100%. And I was looking that Brian Ravitch mentioned that FDA has examination sampling, and he provided an example. So just one thing, Brian Ravitch, about that. whenever you are sampling for biological hazards, I'm going to say biological at this point, okay?
Yeah.
It is possible that that methodology is going to require different number of samples that if you are testing for aflatoxins, or if you are testing in a liquid product, or if you are testing in a dry product. So
Yeah.
thank you very much for sharing with everybody the link. But these are the things that we are exactly talking about. This is about what is the best methodology that people can use for sampling at certain points and for certain things. You are going
Mhm.
to find out that in your entire food safety program, you are going to be using many different sampling techniques for many different things in your process. That's going
Right.
to be the outcome.
Absolutely.
And it's
And
going to be affected by the lot, by the size of the lot, how you define that lot.
yeah. And I mean, what's interesting about this is we got to get this topic in as well, too, right? Because part of this is we're talking about discrete. You're looking for discrete measures within products, right? So chemical and micro and things like this. The third category is organoleptic, right? Of
Oh,
sight,
yeah.
smell, taste, texture, right? Some of these things have instruments that you can measure, some don't, right?
Yep.
So how do you then put together sampling programs for those, right? That gets really, really difficult. And part of this then is figuring out your reference. And a big piece of this, right, is having that consistency, right? Having trained individuals who are doing this so you can hopefully then minimize that error associated with that. But you can't forget those, because part of this, right, within quality, right, we talk about food safety a lot, right, because it's super important. But then there's that quality side of it. There's a certain expectation, right, just like our coffee and our tea. There's a certain expectation the consumer has for those products. You need to understand and sample for those, right?
Yeah.
And you need to be able to then have that analysis process and say, yes, this meets our expectation, or this is drifting, right? Because changes in these areas are incremental over time, and people
Yeah.
miss them. And then all of a sudden, boom, right? You got a big quality problem, and people don't know why. It's
Yep.
because of that side of the things. And when you're looking at things like this, it gets really, really hard to sample. Part of this is having a process in place. And this is why I think control charts and things like this are super valuable, where when things start to drift, just like any good sampling program, you need to pull more samples, right? So if you're doing a flavor analysis on finished products and your team that does that analysis is picking up defects, man, you need to go back and pull more samples, right?
Yes.
You need to figure things out. The whole point of a program like this is to keep those type of defects from going to the market. In these areas, you really, Jose, have two main categories, right? You have that technical expertise, picking up things that a consumer would never complain about, right? So the people that taste coffee and tea, oh my God, those people are experts, right? They can taste a tea and know what part of the world it came from and what crop it came from, and all of these things, right? Just amazing talent in those areas with that type of sensory expertise. You use those things internally to guide your process, with the goal of not getting to the consumer side, right? Because from the consumer perspective, they're not as, it's a bad word to use, but they're not as sophisticated when it comes to that. But that's okay. They have an expectation. And if you get to that point where that expectation is broken, you got a big problem, right? So that is an important part of your sampling plan and procedures that you need to figure out.
Yeah, you need to take that. I mean, 100%. I remember, Bryan, now that you're talking about coffee and tea, I remember going to auditing a huge coffee facility. And they actually do have exactly what you described. They have a group of people. I believe that there were 3 or 4 people, and they were the testers of the taste.
Yes,
And you know, or coffee. Yeah, the smell in that facility was just wonderful. But you know what? You have people that have a very unique ability, which is the taste. You know, you are not going to find that many people that will have that ability and that will be so educated. And I'm not talking about culturally educated on the way that they separate the different flavors and the different textures and so on, that they can actually match on their appreciation. So let me go back one step. Okay, so you're a coffee company and you're going to hire one person that is an expert and is going to give you a great overview. And you start using that person, and suddenly that person says, I'm not going to work for you anymore. Maybe that person retires.
Yeah.
So what's the backup plan? And now let me give you another point of view. So I was in front of 4 people tasting the coffee. They were talking about what they feel when they were, tasting the coffee. And guess what? Their opinions are not 100% exactly the same. So which opinion is going to be used? What is the next testing that you're going to perform in order to try to unify those opinions? And
Right.
this is going to play a role in the outcome of your product.
Mhm.
Like you said, the public may not even sense any difference between those 4 coffees that these guys were trying, or maybe the same coffee that these guys were trying. But you know what? It doesn't matter. Like you said, customers do have an expectation, and it's up to us to go not only just to the bare minimum of that expectation, but going way above that one in order to maintain consistency in the production of the products that we're making.
Right. And this circles back to what I talked about earlier, right? It's that handoff between design control, the development of new products, and passing that information to production so they understand what that is. Because if you don't define that for production, they'll define it themselves.
Yeah,
100%.
of course. Yeah.
So I had at a cheese company I worked at, we had an amazing sensory team. It was led by one woman, and she would train the team. But the important thing we put in place, Jose, is on the line during production, right, as they're pulling samples. And let's take texture, for example. Super, super important on this product. It was a whipped product, and that texture had to be perfect. Because if it was too soft, the consumer would buy it and put their cracker in and go, ugh, right? It was gross. And if it was too hard, it would break the cracker, right? And as a consumer, it's like, oh, right? You're at a party and you're dipping, right? Well, you're complaining, right? That is not a good thing. So that product had to be whipped correctly. So we worked with those operators all the time. And she would train them and take cups and say, see, look at this. See how this works? See how this whips? Now you do it. See that? Okay, here's one that's too soft. Here's one that's too firm. Constant calibration back and forth. And here's the point of this story is we had green, yellow, red zones, Jose. And if that cheese started drifting and it was getting a little too hard or a little too soft, they just couldn't go, and keep running. They had to go to the lab and let the lab know and talk with her or the people she trained and say, how's this? And go, you're right. That's getting a little soft. I think we're okay. We'll put it on hold, but take more samples. You need to keep a close eye on this. If it changes at all, let me know.
Yeah, and just a quick thing for what you are saying, Bryan. And when you're doing that sampling and you're checking for, in this case, organoleptic, you need to take also consideration about the environment that you're testing that, because that texture is not going to be the same at, 40 degrees that and 75 degrees.
Yes, this product, when it was manufactured, was like plus or minus 2 degrees. It had to be super, super, super tight at that measurement point. On that product, right, this product had all kinds of variables associated with this. We had 6 Sigma level complaint rates on that product, right? We had like 1 in a million complaints on these type of products because we were able to catch the defects when they happened, right? So the reason I'm bringing all this up, right, this is kind of to bring this around because we're already coming up on time here already.
Yeah.
If you have a variable product, right, putting in a gigantic sampling program after the defect has been created is a waste of time.
It's a waste
you
of
need
time.
to think creatively and figure out in your process, how do I catch the defect when it happens? Because as quality people, Jose, there's nothing that caused me to pull my hair out more than having the production team come to me and say, hey, Bryan, we made 50,000 cases of bad product yesterday. What do you want to do? What do you mean what I want to do? Don't make bad product. Why is this now my problem?
Yep.
You made bad product. Why did you make bad product? right? And in quality, we tend to take those problems on ourselves and say, oh, geez, let's go back and do all these sampling and programs. And then the production guys go, okay, I'll run on to the next day. No. The goal is to have a program in place and a sampling and measurement system that catches the defects when they happen.
Yep.
Right.
Yep.
And I think that's the main lesson for today. Is if you think that you're going to rely upon finished product testing sampling to control your product, you're going to fail.
Yep.
You are going
exactly right.
Yes.
And actually, we can close, Bryan, saying there is nothing better than have, and I'm going to put this in quotes, preventive controls, because we want to make sure that we put those controls before we have those deviations.
Right. And so, when you pull up little control charts and charts like this, and you go online and you pull in a sampling program, and like we talked about, it comes back with you need to pull 300 samples. That's what they're talking about. They're talking about finished lots of discrete units. Different, right? Don't let that fool you. In process, receiving, processing, packaging, shipping, right? You need to catch those defects. Noreen is absolutely right. You cannot test in quality, right? It needs to be built in as you are doing it, right? So keep the defects out at receiving, find the defects during manufacturing and isolate them and correct them immediately, and never ship bad product as the result, right?
Yep.
Sounds simple, but as we're talking about here, super hard, right? Because you're talking about design control of how you're actually measuring the product. You need to understand what are those parameters technically internally that you control, and what does the consumer care about, right? Because as a quality manager, you need to understand that in order to put together a robust plan of what we're talking about, Jose.
Yeah, I agree.
Yep. And then you can defend it, right? Because if you have a defect in your coffee and you know that the consumers hate bitter, right? Man, you want to get complaints, you make bitter coffee, right? You have to have a program in place that controls that. And you have to find that quickly, right? So if the roaster is roasting too long, or if the quality of the beans is not good, whatever it is, you have to fight to keep bitterness from reaching it to the marketplace.
That is right.
Yep. It seems like every time we have our conversations, Jose, I look at the clock and I'm like, we have barely touched the surface on this, right? And it's that way again this week, right? So sampling, right? Huge program that encompasses everything within your quality management system. And it gets back to your point, Jose, at the beginning. FDA is saying you need to have programs and systems and measurement evaluations that are adequate. You need to figure that out.
Yep.
So good. Any other closing thoughts, my friend?
You know what? I'm going to repeat the same thing as before. Preventive controls. And guess what? My definition of preventive control is not just limited to those controls that we're going to put in place for food safety. I'm going to include in my definition all of the cleaning and all of the calibration and pest control and making sure that employees are clean and that the clothing is clean and that the maintenance program is effectively working. All of those are preventive controls because we are maintaining the quality of our product by being consistent on what we do.
Yep. All right. So, thinking in terms of food safety, food quality, operations, right? Those type of things.
Yeah.
Yep. So we'll end the program here. We'll say goodbye to Mr. Faj there. I like Mr. Faj. And we'll be back here, of course, next week at the same time. So Friday at 10 a.m. Eastern. Now, part of this too, right, is this is interactive. And thank you, everybody, for all your questions and information relative to the program. Making it a exchange of information is what makes this so valuable. So also, what do you want us to talk about? Right? We enjoy, and we've had other shows in the past where people have suggested the topic and then we've done that topic. So on the screens here are our emails. Reach out to us and suggest a topic. What would you like us to talk about and chat about from a food safety and quality standpoint on this show? So please send in your suggestions. We love to do them. So with that, we are out of here for this week. Another one's in the can. Anything else, Jose?
Have a great weekend.
Thanks, everybody. We appreciate it. Have a good weekend and put in good sampling programs, and we'll see you soon.
Yep. Bye-bye.